Okay, so we're going to do an example of sketching the graph of each inequality. Well, here we have a quadratic, and I notice right away that this one's factorable. The factors of 3 and 1, do add up to 4. So we can go ahead and put x plus 3, x plus 1, and then remember to find what the factors are. You use the zero property, or just ask yourself, what's the additive inverse of positive 3? Well, that would be negative 3. And what's the additive inverse of positive 1? Negative 1. So right there, right away, we know those are our x-intercepts. So x is equal to negative 3, and x is equal to negative 1. So we know those are 2 points. Well, we also know that this constant right here, that's where it's going to touch the y-axis. Well, if we are 2 away and up 3, on the other side, we can go 2 away and up 3, so we're not quite 2 away, but it'll be over there someplace. And we know that halfway between those two will be the axis of symmetry. And invisible. And that's where the vertex point will be. So since that's at negative 2, all we have to do is plug negative 2 into that original function. So negative 2 squared plus 4 times negative 2 plus 3. Well, negative 2 squared is 4. 4 times negative 2 is negative 8. 4 subtract 8 is negative 4. Negative 4 plus 3 is negative 1. So at negative 2, negative 1, and there you go. So pretty easy. And this is a solid line, so our line will be solid. And remember, you draw it curved. You don't draw a V value. It'll look something like that, and then you can put arrows at the end. Now this says y are all the values greater than. So when we're looking at that y-axis right there, where do the y values get bigger? Well, you can see bigger than 3 is 3.5. So above that line, well, above that line falls inside the parabola. So you shade everywhere on the inside of that parabola. Okay, let's look at another one really quickly. I'm going to cover up all this stuff. So this says y is less than. We've got this parabola. That one is not factorable. So there's a couple things you could do. You could do the table of values. We know right away, let me see if, we know right away that the y-axis will touch right there at 2. I'm not sure what else is happening. You could do the quadratic equation, but the easiest thing that we could do is find the vertex value, because remember the vertex is that low point. If we know this point, we can just make it symmetrical and then sketch the graph. So the vertex value, x is equal to the opposite of b over 2 times a. Well, in this case, the opposite of negative 2 is positive 2 over 2 times, well, that invisible a is 1. Well, 2 divided by 2 is 1. And then to find the y value of the vertex, you plug 1 into that function. So 1 squared, subtract 2 times 1, plus 2. Well, 1 squared is 1, subtract 2, plus 2. Well, negative 2 plus 2 cancel out, so that leaves the vertex is at 1, 1. So at 1, 1, I can put a dot. Well, that means since this is symmetrical, remember, if it's the vertex point, there'll be an axis of symmetry. that runs through the vertex. And now we have enough information. This is y is greater than, I'm going to change that to blue, so that will be a dashed line, or what this y is less than. It's not a solid line, so we're going to, and now when we're looking right here, where are the y's less than 2? Well, they're less than 2 down below, and that's not on the inside. So everywhere on the outside, you shade. That's it.